Alright, in this video we are going to talk about equations of circles, so a little bit of algebra mixed in here. So the equation of a circle looks like this, that hk, so h is just the x-coordinate, k is the y-coordinate, and r is the length of the radius. We can write the equation of a circle like this: x minus h squared plus y minus k squared equals r squared. Okay, so this formula will plot every single point that is a distance of r away from a certain center hk. Okay, so let's do a couple of quick examples of writing an equation of a circle. All right, so let's say we're given the center of -1, 3 and a radius of 6. So our equation, x minus h squared plus y minus k squared equals r squared. We're just going to plug these three pieces of information in. So this is my h, this is my k, and this is my r. So I'm going to have x minus -1. So that would actually just end up being x plus 1 squared, then plus y minus 3. Y minus 3 squared equals 6 squared, and 6 squared is just 36. Okay, so this would be the equation of the circle centered at -1, 3 with a radius of 6. All right, let's do one more like that here. All right, so let's say we're given a center of -2, 3 and a radius of 5. So again, my standard form of a circle is x minus h squared plus y minus k squared equals r squared. So just plugging these pieces of information in, we will have x minus -2, which would be x plus 2 squared, and then plus y minus 3 squared equals 5 squared, which would be 25. So this is the equation of this circle. Right? How about something like this? How about a center at 0, 0 with a radius of 8? Okay, well again, using our formula, we will just plug those three pieces of information in. So I'm plugging 0 in for both h and k. So I'll have x minus 0 squared plus y minus 0 squared equals 8 squared is 64. Now we can actually clean this up a little bit. X minus 0 is just x, so I could just write this as x squared plus, then same thing here, plus y squared equals 64. Okay, so if we see something like this, we can automatically assume that this is minus 0. Right? How about one where we're given the diameter instead of the radius? Okay? If we're thinking about writing the equation of a circle, we always need the same two pieces of information, the center and the radius. Well, if we're given the diameter, we know that the radius is just exactly half of the diameter. So if the diameter is 8, the radius is 4. And then we can do exactly what we were doing, plugging those three pieces of information into our formula. So we'll end up with x minus -2, so x plus 2 squared plus y minus -6, so y plus 6 squared equals 4 squared, which is 16. And this would be the equation of that circle. All right. How about something like this? If we're given the center, but then we're just told a random point that the circle passes through. Okay, so let's think about what that would look like on the graph. Okay, so my center is at the point 3, -4. So here's my center. And then the circle, which is out here somewhere, goes through the point -1, -1, 2, 3, 4. right? So what we want to think about, here's the center, here's some random point on the circle. That distance between those 2 points, okay, the distance between the center and some point on the circle is the radius, right? So in this case, I can just actually count the radius since that's on a nice straight line. So my radius would be 1, 2, 3, 4. So we have our center and we have a radius of 4. So now I can plug that information into this formula. So the equation of this circle is going to be x minus 3 squared plus y plus 4, right? Y minus negative 4 squared equals my radius of 4 squared, so 16. So this would be the equation of this circle. And since we already have some of it plotted here, let's go ahead and actually graph the rest of that circle. So this circle would look something like this, all right? Centered here with a radius of 4. So this would be what the graph of that circle looks like, all right? Now, sometimes on problems like this, it won't be as easy to just count the radius, okay? Sometimes we may actually have to use the distance formula to calculate the radius. So let me run through that real quick on this problem, all right? So if I'm given the center and the radius, the center and a random point, we could find the radius by using the distance formula. So I could say that my radius is equal to the square root, and this is the distance formula, right? x2 minus x1 squared plus y2 minus y1 squared. So for this one, that'll end up being negative 1 minus 3 squared plus negative 4 minus negative 4 squared. So we get negative 4 squared plus 0 squared, which ends up just being the square root of, this would be positive 16, and the square root of 16 is 4. And that's what we found just by counting, right? We got that the radius was 4. So in this problem, we could make it a little simpler since this was on a perfect straight line, but it won't always be like that. Sometimes we'll need to use the distance formula to calculate the length of the radius if we're given the center and a point that the circle passes through, right? So now, what about if we're given a graph? How can I write the equation of the circle? Well, I still need those same 2 pieces of information. I need the center and I need the radius. So just by looking at the graph, I can see that the center of the circle is at negative 2, negative 1. And I can see that the radius, the distance from the center to a point on the circle, is 1, 2. So now, with this information, we can plug that into x minus h squared plus y minus k squared equals r squared. So we'll end up with x plus 2 squared plus y plus 1 squared equals 2 squared, which is 4. So this is the equation of this circle. All right. Let's do one more of those. So here, the center of the circle is at the point 1, 3. And the radius, which is the distance from the center to a point on the edge, is 1, 2, 3. Okay, and we can get that by counting from here to here, or here to here, or here to here, right? Lots of ways to count the radius. So then, if I plug that information into x minus h squared plus y minus k squared equals r squared, we will end up with x minus 1 squared plus y minus 3 squared equals 3 squared, which is 9. All right. So now let's take a look at going backwards. Let's say, given the equation, let's graph, right? So we always need those same two pieces of information. We need the center and the radius. So from the equation now, let's pull out the center and the radius. So the center is going to be at the point -3, -1. Remember, if we're thinking that this is x minus h, okay? Oh yeah. So this would be x minus -3, and this would be y minus -1, okay? So the x coordinate would be -3, y coordinate -1, and then the radius is going to be the square root of this value, right? Because if this is r squared, the radius will be the square root of that. So the square root of 9 is 3. So if we go to -3, -1, that's my center. And then if we wanted to graph this by hand, I would want to go 3 to the right, and 3 to the left, and 3 up, and 3 down. All right, but I'm going to use the circle tool here to draw this nicely. Oops. So we should end up with something that looks like that. Okay, a circle centered at -3, -1 with a radius of 3. Right? Let's try another one here. How about x squared plus y squared equals 16? So remember, we already talked about if there isn't a number added or subtracted inside here, we can assume that that's 0. So my center here would be the point 0, 0, and then my radius would be the square root of 16, which would just be 4. So center at 0, 0, and then I'm going 4 in each direction. 4. So then we should get a circle, something like that. All right. Let's move on to one like this. How about we are just given 2 points on the circle, and we're told that these are endpoints of the diameter. Right? Well, we still need those same 2 pieces of information. We need the center and the radius, just from knowing these endpoints of the diameter. Well, let's first plot them and see what we're working with. So -2, 2, there's F, and then G is at 4, -4. So here is G. So the line between those is a diameter of my circle. So first, we can find the radius of the circle if I find the distance between those and then take half of that. So we want to use the distance formula. Right? So let's say distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. So I can label my points x1, y1, x2, y2, and then plug them in. So we will have 4 minus -2 squared plus -4 minus 2 squared. So that ends up being 6 squared plus -6 squared, which will be 36 plus 36, which is the square root of 72. So I'm actually going to leave that as the square root of 72 for now. Okay. So we'll say that the diameter is the square root of 72. Well, the radius then is going to be half of that. So the radius, and I'm just going to write it like this, the square root of 72 divided by 2. Okay, I'm taking half of my diameter. Well, then we still need the center. Well, if these are endpoints of the diameter, to find the center, I can just find the midpoint between these 2 points. So my center is going to be the midpoint, and our midpoint formula was this, x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So if I plug those points in, I'll have negative 2 plus 4 divided by 2, and 2 plus negative 4 divided by 2, which gets me negative 2 plus 4 is 2, 2 divided by 2 is 1, 2 plus negative 4 is negative 2, divided by 2 would be negative 1. So my center is at the point 1, negative 1. So there's the center of my circle. So now I can write my equation. Okay, my equation is in this form, x minus h squared plus y minus k squared equals r squared. So if I plug in my information, my center at 1, negative 1, so I'll have x minus 1 squared plus y plus 1 squared equals this, my radius, which is the square root of 72 over 2 squared. Now let's clean this up a little bit here. So if I square a fraction, we need to square the numerator and square the denominator. So if I square the numerator, the square root of 72 squared is just 72. And then if I square the denominator, 2 squared is going to be 4. So then 72 divided by 4 gets me 18. So this would be my final answer. Okay, this one was a little bit of work. Right? We had to find the diameter first using the distance formula, take half of that to get the radius. Then we needed to use the midpoint formula to get the center of the circle. Then we plugged those 2 pieces of information into our formula for a circle, and then we had to simplify this radius a little bit. Okay, so there is an edge elastic up for you guys to try some problems like this. Right? Please send me any questions that you have. And remember, your assignment for today is to upload a picture of your notes to Schoology. And then tomorrow's assignment is the edge elastic.